All right, so have you ever seen those mind-bending puzzles? The kind that, like, even we humans struggle with?
Oh, yeah, those are tough.
Well, get this. Researchers at MIT, they're using something called test time training to help AI tackle those challenges.
Wow, that's interesting. Test time training, huh?
Yeah, it's like imagine giving the AI a last-minute cram session right before a huge exam.
Makes sense. So what kind of puzzles are we talking about here?
They've been working with the Abstraction and Reasoning Corpus. It's shortened to ARC.
Okay, ARC. And what is that exactly?
It's this collection of visual puzzles. They really test an AI's ability to reason. And trust me, they're not easy. Even some of the most advanced language models initially, they were totally stumped.
So how did they get these AIs to, actually solve these puzzles?
That's where the test time training comes in. They figured out a way to like boost the AI's performance using this technique. It's pretty amazing.
I bet. So how does it work? What's the secret sauce?
Well, they found three key ingredients that make it really effective. First, you got to pre-train the model on similar tasks, get it familiar with the territory.
Okay, pre-training, that makes sense.
What else? Then you have to augment the training data, but you got to do it in a clever way.
Hmm, interesting. And the third ingredient?
The third thing is creating these specialized adapters. But for each puzzle, it's like giving them a tailored toolkit.
Killer toolkit. I like that. Okay, so we have the ingredients, but how do they actually use this test time training? Like, what's the process?
All right, let's break it down. So first, you have to make these visual puzzles understandable for a language model. And language models, they basically think in words.
Right. So it's like trying to explain a picture to someone who can only read descriptions. They can't actually see it.
Exactly. And that's the challenge they face.
So how they solve that?
They converted the visual puzzles into text. They used a special formatting function.
Oh, I see. Like translating the puzzle's language into something the model can understand.
Exactly. So now the model can read the puzzle. But how does it actually learn to solve it?
Yeah, that's the big question.
Well, large language models, they have this incredible ability called in-context learning.
In-context learning, I've heard of that.
Yeah,
It's like they can pick up new skills just by seeing a few examples, right?
right. Like they don't need someone to reprogram their entire system. They can just adapt on the fly.
That's wild.
Yeah.
But I'm guessing in-context learning isn't always enough, especially for something as complex as these ARC puzzles.
You got it. It's like expecting someone who's only played tic-tac-toe to suddenly become a chess grandmaster just from watching a couple of games.
Yeah, they'd need way more focused practice.
And that is where test time training swoops in, like a superhero. It gives the model that extra practice time, and it's tailored to each puzzle.
So it helps bridge the gap between what the model already knows and those specific puzzle challenges.
Exactly. It refines the model's approach based on each puzzle's quirks.
I like that. Refining the approach. So how did they create the training data for this test time training?
They created a special data set just for it. They used a two-step process.
Two steps. Okay, tell me more.
Step one, they had these things called leave one out tasks.
Leave one out. Interesting name. What's that?
Imagine you have some practice examples for a puzzle, right? Well, they would hide one of the examples and then ask the model to predict it. But it could only use the other examples.
So it's like a pop quiz. They're making sure the model really gets the concept, not just memorizing answers.
Exactly. And this leave one out strategy, it does something else really important.
What's that?
It mimics the actual test conditions.
Mhm.
Because, the AI won't have all the answers during the real test.
Right, it has to think for itself. This is brilliant.
Yeah, it forces it to come up with solutions, even with incomplete information. And it makes the training more efficient, too.
More efficient. How so?
They didn't have to train the model on every single combination of examples, just the ones that really mattered.
Smart. Okay, so that's step one. What about step two?
Step two, they got super creative. They called it rule-based augmentations. They'd flip the puzzles, rotate them, even recolor them, just to create tons of variations.
Whoa, hold on. They were just messing around with the puzzles?
Not randomly. It was all very controlled. They had specific transformations to preserve the core relationships within the puzzle.
Okay, that makes more sense. So give me an example.
Like, they might flip a puzzle horizontally, like you're looking at it in a mirror. This helps the AI understand that the solution isn't about the absolute position of things, but the relationships between them.
That's really clever. So they created this super diverse training set. But how did they actually train the model using it?
They use something called low-rank adaptation, or LoRA for short.
Flora. Got it. And what does that do?
It lets them fine-tune the model during this test time training. but they don't have to update all the parameters, which would take forever.
So it's like giving the model a specialized toolkit for each puzzle. It can adapt quickly without losing all the general knowledge it has.
You got it. Efficiency is key here. Makes the model much more flexible.
I see. Okay, so now the model is all prepped for the puzzle, thanks to the test time training. But how does it actually come up with a solution? How does it use all that training?
That's where things get even more interesting. They used a technique called augmented inference. It's like solving the puzzle from multiple perspectives at once.
Multiple perspectives. Can you elaborate on that?
Think of it like having a team of experts all working on the same problem.
Okay, I'm following.
They might each have a slightly different approach, but by combining their insights, they're more likely to get the best solution.
That makes sense. So how do you make sure the AI doesn't just get confused by all these different perspectives?
They use something called hierarchical voting.
Hierarchical voting. Okay, you're going to have to explain that one.
Imagine each of those different puzzle-solving experts gets a vote on the final answer. The most popular answer wins.
Ah, so it's all about consistency across different perspectives. Makes the AI less likely to just guess randomly, right?
Right. It helps it arrive at a more reliable solution. It's not about luck. It's about finding the answer that makes sense from multiple viewpoints.
This is fascinating. Okay, so they put all this effort into training and testing, but did it actually work? Did all this fancy footwork pay off?
Oh, absolutely. The results were pretty remarkable. This test time training approach, it significantly boosted the performance of language models on ARC.
Significantly. How much are we talking?
Well, they actually surpassed some specialized AI systems, ones that were specifically designed for this type of reasoning. It's like they took a regular language model and turned it into like a reasoning superstar.
Wow, that's incredible. So we've covered how they trained the model during test time. But what about before the test? Did they do anything special to prepare the model, like, pre-test training?
Yes, they actually used a few different methods to fine-tune the model before the test time training even started.
Oh, okay. So
Yeah.
like giving it a solid foundation before that last-minute cram session.
Exactly. One method was they took existing code that was designed to generate ARC puzzles, and they used it to make a bunch of new practice puzzles, like giving the model a textbook full of problems.
Makes sense. A pretty common strategy in AI training, right? Using existing resources to generate new data.
Right. It helps expose the model to a wider range of examples, but of course, there are limitations.
Yeah.
Okay, so using existing code makes sense, but they didn't stop there.
Nope. They actually used a language model to design completely new puzzles.
Wait, really? An AI was designing puzzles for another AI to solve? That's meta.
Exactly. And they even had this special code to generate these new puzzles so they could make a bunch of them.
So it's like the AI is creating its own study guide. That's wild.
It is pretty wild. And on top of all that, they use those geometric transformations, the ones we talked about earlier, to create even more variations in the data. Flipping, rotating, the whole shebang.
Like they wanted to make sure the AI saw those puzzles from every possible angle. Smart.
Exactly. Show the model the same concept, but in a bunch of different ways. Helps it develop a more flexible understanding.
So they used human design puzzles, AI generated puzzles, and all those transformations. Which ones worked best?
Well, using the existing code to generate new puzzles, that worked really well. It led to a big improvement.
More practice, better results. Makes sense to me. What about the AI generated puzzles? How did those do?
Here's the thing. Those actually made the performance worse.
Wait, but I thought AI generated data was supposed to be like the next big thing.
It is a powerful tool. But the AI puzzle generation methods, they still have some limitations.
Like what?
The puzzles the AI created, they were often too simple or too similar to the ones that already existed. They didn't really challenge the AI enough.
So it's like giving a student a bunch of easy practice problems. They might feel good about themselves, but they're not really learning, are they?
Exactly. It shows how important it is to really check the quality of AI-generated data. It's not just about the quantity. It has to actually help the model learn.
Okay, so we've got all this pre-test fine-tuning, and then that test time training crash course. How did it all come together in the end, like on the real test?
They use the ARC evaluation set. That's the real deal.
What did the model do?
With the help of test time training, the model got an impressive 47.1% accuracy.
47.1%. That's a huge jump, isn't it?
It is. But, the top human scores on ARC, those are close to 98%. So there's still a gap.
Right. So how do we close that gap? How do we get the AI up to human level?
Well, they combine their method with another technique. It's called BRRC. Stands for Bootstrapped ARC.
BRC. Got it. And what does BRC do?
It uses a bunch of different AI approaches to solve the puzzles.
A combination approach. Interesting.
Yeah, and get this. When they combine their test time training with BRC, they hit a new record. 61.9% accuracy.
Wow. 61.9%. That's almost the average human score, isn't it?
Yeah. Average human score is about 60.2%. So they're right there.
That's amazing. They're practically at human level. So where do we go from here? What's next for test time training?
Well, think about all the potential applications. If test time training can unlock this level of reasoning, what other complex problems can we solve?
That's a great question. What are you thinking?
Imagine using this in scientific discovery. AI systems that can analyze data, find patterns, even come up with new hypotheses.
That would be incredible. What about medicine? Could it help with diagnoses?
Definitely. AI could help doctors make diagnoses faster and more accurately. It
Okay.
could consider the patient's whole medical history and all the latest research.
Wow. And what about creative fields? Music, writing, design? Could AI do those things too?
Absolutely. If we can teach it to reason and adapt in real time, the creative possibilities are endless.
It's pretty mind-blowing to think about all the ways AI could change our world. But with all this power comes responsibility, right?
Mm.
What about the ethical implications?
You're right. That's a crucial part of this. As AI gets more powerful, we need to think carefully about the ethics.
Things like fairness, bias, transparency, those are all really important.
Absolutely. We have to make sure AI is developed and used responsibly. It should benefit humanity as a whole.
Well said. Okay, so we've covered a lot of ground here. We talked about how test time training lets AI adapt and improve even during the test itself. And we discussed the three key ingredients for success.
Right. Pre-training, data augmentation, and those specialized adapters. We also talked about how important it is to fine-tune the model before the test, but the methods you use really matter.
And finally, we saw how combining test time training with other techniques, like BRO, can lead to some truly impressive results. It seems like the future of AI is all about collaboration.
It really is. Combining the strengths of different approaches to overcome limitations and make big discoveries, that's what's moving the field forward.
So, test time training can help AI achieve this amazing level of reasoning. What other complex problems could we tackle in the future? I guess that's something to think about.
It is. The possibilities are pretty much endless.
Well, that brings us to the end of part 2 of our deep dive into test time training.
It's been a great discussion. Hopefully you've all learned something new about this incredible technology.
And if you want to learn even more, be sure to check out the show notes. We've got links to all the research, some resources to explore, and even some interactive demos. You can experience the power of test time training for yourself.
Definitely check those out. It's worth it.
Until next time, keep learning, keep asking questions, and keep diving deep into the world of knowledge. See you all soon. Welcome back to our deep dive on test time training. It's been quite a journey so far. We've gone from the basics to some pretty big questions about, the future and ethics.
It has been a lot to cover, but now I think it's time to get practical. Let's see how test time training is actually being used out there in the real world.
Sounds good to me. Where should we start?
Well, one area where it's showing a lot of promise is robotics.
Robots. Okay, that sounds cool. What kind of stuff are we talking about?
Imagine a robot that needs to learn how to, pick up all kinds of objects,
Mm.
different shapes, sizes, textures. The old way of doing it, you'd have to train it on this massive data set of images, which takes forever and costs a ton.
Yeah, and wouldn't that make the robot kind of inflexible? Like it could only handle things it's seen before.
Exactly. But with test time training, the robot can learn and adapt on the fly. It could start with just a few examples and then refine its skills as it encounters new objects.
So it's like the robot is constantly learning from experience, just like we do.
Precisely. And that makes it perfect for robots working in environments that are always changing, where it might run into something it's never seen before.
That's pretty amazing. I can see how this could be huge for like manufacturing, healthcare, even space exploration.
Absolutely. But robotics is just one area. Test time training is also making waves in natural language processing, NLP, as it's called.
NLP, right? That's all about AI understanding and, generating human language.
Right. And one of the biggest challenges in NLP is dealing with ambiguity. Like the same word can have multiple meanings. People use slang, expressions. All that stuff can trip up AI.
Yeah, sometimes even I have trouble figuring out what people are saying.
Well, Test time training can help AI systems get much better at handling those tricky situations. Like imagine a chatbot. A chatbot trained with TTT could learn to figure out what a user means, even if they're using slang or being indirect.
So it's like the chatbot is learning to read between the lines, like a human would in a conversation.
Exactly. And that makes TTT really valuable for things like chatbots, virtual assistants, anything that needs to communicate with people.
So test time training is already having a big impact, but what about the future? What are the challenges? And the opportunities?
Well, one big challenge is scalability. As AI models keep getting bigger and more complex, test time training gets more expensive. Computationally speaking, it takes a lot of power to do it.
So researchers are working on making it more efficient.
Exactly. More efficient algorithms, faster hardware, that sort of thing.
It's a race then. As the models grow, the training has to keep up. What else?
Another challenge is figuring out how to measure the performance of TTT systems, especially in real-world situations. We need better ways to assess how well they're adapting and generalizing.
So it's like we need a standardized test for TTT, something that gives us a clear picture of how well these systems are doing. Makes sense.
Right. And of course, we always need to keep those ethical considerations in mind. Fairness, bias, transparency. We can't forget about those things.
Definitely. The excitement of this new technology shouldn't overshadow those potential risks. We have to be responsible.
Absolutely. But, with careful thought, continued research, test time training has the potential to revolutionize AI. We could see levels of intelligence and adaptability that we never thought possible.
It's definitely an exciting time to be following this field. Well, I think that brings us to the end of our deep dive into test time training. We've covered a lot of ground.
We have, from those core concepts to real-world applications. We've even touched on some of the big challenges and opportunities ahead.
If you want to learn more, check out the show notes. We have links to the research, some resources to explore, and even some interactive demos, so you can experience the power of test time training firsthand.
Definitely check those out. They're worth exploring.
Until next time, keep learning, keep asking questions, and keep on diving deep into the world of knowledge. Thanks for listening.